Hey everybody, let's do another problem from this test. It's from 2020 JEE Advanced Physics Paper 1 and this question 10. So actually this is a nice question in kinematics. So a charged particle enters a uniform. So this is interesting part is this is uniform. So if the charge is say E, this particle has charge E, or let's call it Q, then the force on charge will be Q times E in terms of magnitude. And if it's a positive charge, then the force will be in the direction of the electric field. And if it's a negative charge, the force will be on that side. So this is a positive charge. So this is positive charge. So the force on Q is also down. Okay. And it is this is constant because of uniform, so this is constant force. So it's kind of like an mg kind of force. Okay. So if you look at the acceleration, so QE is force and mass times the acceleration. So acceleration will be pointed down because this force is pointed down. Mass is positive, so the acceleration is pointed down. So the acceleration of the particle will be pointed down. So it's kind of like a shot a ball, and ball will go and come down. So there's some angles at which you might shoot the ball and to hit the point level T here. That's a target. So initially speed is given and where ball is supposed to land. Then maybe another angle, or if the angle is different, it might come down like that. So there's a question here. The angle can be 30 degrees or 60 degrees or 45 degrees. There's a fixed angle, particular angle, or there could be two different angles. So we need to decide on by solving this problem if that's the case for these numbers given. This 5 meter initial speed is this, and electric field value is that, and charge over mass ratio is that. Why do we need charge over mass ratio? You can look at here. You can see that I can get acceleration by charge over mass ratio times electric field. So just looking at the magnitude part, not the direction part. So this 10 to the power 10 times 400 is square root of 3, and that's going to be meter over second square. So this is the acceleration in the y. If this is the x direction and this is the y direction, then the acceleration in the y direction is minus a, because of the direction. Of course, ax, there's no in that direction. Ax is 0. So this is just a projectile motion problem, right? So these two questions about whether there are two angles like this and this, or there's only one angle. And this is about could time be this as well as this, or there's only one time. So you can see that these two are kind of tied, and these two probably are tied. So I don't know. Often looks like two answers for this may lead to two answers for that. One answer for this may lead to one answer for that. So that's just a guess. We have to work it out. Okay, so how do we work it out? We know the acceleration like that. So because distance in x is given, so v0x doesn't change because of this. So along x is v0x, and let t equal to 0 here and t equals to capital T here. Can be two t's, I don't know, just that t will be this distance 5 meter. These are not known. v0x will be u cosine theta, u cosine theta. So u is known, but theta and t are not known, and u is this number. This u is that number. So along x-axis and along y-axis the distance is 0, so I can use delta y equals to v0 yt plus half ay t squared from going from here to there. This is 0, and the t can be taken out. So but t is not 0, is going to another place, so this is not 0, so that's the case, and this t becomes capital T, and this a is ay is this value, and v0y is so 0 equals to v0 or u sine theta minus half times 10 to the power 10 times 400 times square root 3 t. So you can see that so let's write this 5 over t and write this equal to that. So this is equation number 2. If I multiply, t will go away, right? When multiplied, so I got a u square sine theta cosine theta equals this becomes 200, 10 to the power 10 times 200 is square root 3 times 5 times 5. If I multiply divide by 2 and multiply by 2, this becomes a sine 2 theta. So sine 2 theta is from 2 over there. That makes it again 400. 5 times 400 is square root of 3 times 10 to the power 10 divided by u square, and u square will be 4 times 10 times 10 to the power 12. So we have here is 2, and this becomes 100. 100 with 10 to the 10 would cancel out that guy. This cancel that guy. So I get a square root of 3 over 2. But this is 2 theta. The range of theta is between 0 and 90 degrees. So range of 2 theta is between 180 degrees and 0. So when sine 2 theta is square root of 2, 2 theta in this range can be 60 degrees or 120 degrees. Both of this. If you look at sine theta is 0 and 180 degrees, and this square root of 3 over 2 is going to cut here and here. at 60 degrees and 120 degrees. Okay. Then theta is going to be 30 degrees and 60 degrees. So that's that's one of the things you might miss, because you got to know that theta is in that range, makes it 2 theta in this bigger range, and then you can catch the b is correct. Okay, so decide. So a is definitely not correct. Let me clean this a little bit up, and so I can do the c. All right. Okay, so to get decided in 2 different times, I need to get for these two different theta values, find t from any either over here, y equation or x equation. Suppose so if theta is 30 degrees, cosine theta is going to be square root of 3 over 2. If theta is 60 degrees, then cosine theta equal be half. So depending on that, let's use this, okay? So t is equal to 5 over u cosine theta. So this will be, we can just figure that one out separately, and u is 2 square root of 10 times 10 to the 6, and that's in the second, so this will be seconds cosine theta. So if take this out, that will going to be microseconds, and this is so it's a half. One of the square root cancels out, so this is going to be 5 over 2 using these two. 1 over cosine theta microseconds. So let's see, there are going to be two answers. So theta 30 degrees makes it half square root of 5 over 2 and 2 over square root of 3. So this is square root of 5 over 6. And when theta is 60 degrees, is half square root of 5 over 2, 1 over 2. So it's square root of 5 over 2. So it's this and this, both of them, and that's correct. And so this is not correct. Okay, so this was kind of pretty straightforward problem. Once you recognize it's nothing but regular projectile motion problem, and you just have to make sure that the your signs are correct, because this is, if you put a y like that going up, then an x this way, y going up, then these guys are all negative, axis is negative. Another thing that we need to make sure that we know is QE will just be mass times A in this situation. This will be the force and then mass times acceleration. And this is the y component. Y component of F equals ma looks like that. We're assuming that this is all very much, the speed is not the speed close to the speed of light, so there's no reason to just go into relativity and complicate problem. But if you had a very high speed, the problem could complicate a little bit. But this is high speed, but not the high speed comparable to 10 to the power 8 meter per second speed of light. So we don't go into relativity. Okay, it'll be interesting for you as an exercise. What if this guy had a speed which was 2 times 10 to the power 8 meter per second, and he's short like that? What will be the trajectory like? Okay, and I'll leave that as an exercise for you. It's an interesting problem. Okay. Having said that, we are going to stop this problem, and we will see you in another video. Bye.